Let us see how we can deal with the given problem and find out the value of x. Now you may use different kinds of methods to compute for the value of x, but in this video I'm going to be using three such methods that we can use to find out the value of x. So let's get started. So I have written down the methods that we'll be using to deal with the given problem. Method 1 deals with the separation of numbers and variables. That means we are going to write numbers on one side and variables on the other side. Method 2 deals with using the Lambert-W function to solve for the value of x. And method 3 is the graphical method, where we'll plot for the given function and see where y is equal to 0 for the given value of x. So yeah, let's get started with method 1. Now let us write down what is given in the question. We have 3 to the power x is equal to x to the power 9. Now in this method, what we do is play with the powers a little, right? So what I will do is I will multiply the powers by 1 over 9 on both sides. Now this gives me 3 to the power x over 9 is equal to x. What I'll be doing now is multiplying the power by 1 over x on both sides. So 3 to the power x over 9 multiplied by 1 over x is equal to x to the power 1 over x. Now this x and this x gets cancelled out, which gives me 3 to the power 1 over 9 is equal to x to the power 1 over x. Now we have to try to convert this term into this form, which is x to the power 1 upon x. And 3 to the power 1 over 9 is not in this form. So what we'll do is again play with the power a bit. What we do is multiply this power with 3 by 3. 3 by 3 is equal to 1. That means it gives the same thing. So there is no problem multiplying this here. This gives me x to the power 1 over x. Now what we'll do is write this in this form. 3 multiplied by 1 over 27 is equal to x to the power 1 over x. And this is the part where the magic happens. We can write 3 to the power 3 as 27 to the power 1 over 27 is equal to x to the power 1 over x. Now this is in the form of x to the power 1 over x. So we can say that x is equal to 27. So this is going to be the first value, the first real solution that will satisfy the given equation. Now, let us try using the Lambert-W function to deal with this problem. Now let us see what answers we obtain from method 2. Let us write down the given equation. We have 3 to the power x is equal to x to the power 9. Now let's apply log on both sides. Applying log on both sides. We have log 3 to the x is equal to log x to the power 9. This gives me x log 3 is equal to 9 log x. Now let us divide by 9 on both sides. Then we'll have x log 3 over 9 is equal to log x. Now let me assume something. Let me say c is a variable which is equal to log 3 over 9 for simplicity. And if I substitute this value in this equation, then we'll have x times c is equal to log x. And now we can write this in exponential form, which is given by e to the power xc is equal to x. Alright, now what? Now this is the point where we use the Lambert-W function. And before going any further, we'll have to understand what Lambert-W function is. So let us see. To understand it in short, let's say that I have an equation in the form y multiplied by e to the y is equal to z. And if I apply product log or w on both sides, then I'll have w of z is equal to the same value here, which is equal to y. This is what Lambert-W function says. And now we are going to use the same thing. We are going to convert this equation into this form and apply w on both sides to find out the value of x. So now let's do that. Let us try to convert equation 1 in this form now. I have from 1 e to the power xc is equal to x. And I can see here that y and e to the y is on the same side here. So I'll try to bring e to the power xc onto the other side. So I'll divide it by e to the power xc on both sides, which gives me x multiplied by 1 over e to the xc is equal to 1. And now if I want to bring this in the numerator, I'll have x multiplied by e to the power minus xc is equal to 1. Now this is almost in this form. Now all I have to do is look at the power here. I have e to the power minus xc, but here is only x. I will need to have minus c so that I have this exact form. So let us multiply the given equation by minus c on both sides, and we'll have minus cx multiplied by e to the power minus xc is equal to minus c. And now this is exactly in this form, which means now I can apply the Lambert W function or the product log on both sides. This gives me, this would mean minus cx is equal to w of minus c. This gives us x is equal to w of minus c divided by minus c. And this is the solution. But wait, is x is equal to 27 the only solution? No, there is another solution as well, which is given by this value. And in order to show both values, we have to check one condition. And to check that condition, the z value, which is in this case minus c, would be very helpful. We have to check if c or minus c lies in the interval -1 over e, comma 0. And if it does, then there are two possible solutions for which the equation this would be satisfied. So let us try to find out. Here, -1 over e would be equal to minus of 0.367, and minus c would be equal to minus 0.122. And we see that minus 0.122 lies between minus 0.367 and 0. So we can conclude that there are two solutions which will satisfy the given equation. And those solutions can be given by x is equal to w0 of minus c over minus c, and x is equal to w minus 1 of minus c over minus c. And now if we substitute these values in a product log calculator, then we can obtain the values for x. Approximately in this case, x would be equal to 1.1508, and from this part, x would be equal to x is equal to 27. So we got x is equal to 27 from method 1, 2, and in this case too, we obtained the same value with an additional x value of 1.1508 that will satisfy the given equation. And now method 3 is about the graph here. If we plot the graph for y is equal to 3 to the x minus x to the power of 9, then we can find out the value of x where y is equal to 0. Like there is a graph, and now if we try to plot it, let's say something like this, it will intersect at this point, which is x is equal to 1.1508, and somewhere around here we will have x is equal to 27 where y would be equal to 0. So we have got two solutions from this method as well. In this way, we have successfully found out the values of x that will satisfy the given equation. And that's our solution.